Everything you have ever done is finished. That is the one thing existence seems to promise without conditions. The future can take things from you, but the past is closed, filed, safe, because it already happened and nothing can reach in and unhappen it. And then there is a laser on a table in a dark room in Maryland, pointed at a barrier with two narrow slits that appears to say otherwise. A particle lands, its position is written down, and only afterward, by chance, by a piece of glass with nobody watching, is it decided whether the record of its journey survives, and the pattern already written seems to depend on the choice that had not been made yet. For 25 years, that has been the most persuasive evidence anyone has that the past is negotiable. It is real, it was published, and what it actually means is worse. So what exactly did you think was back there, waiting to be changed? Settle in tonight, subscribe if you haven't already, and stick around, because by the end of tonight you will know precisely what this experiment shows, what it does not show, and why the honest answer is the one nobody finds comforting. Let's begin. Part 1. The story. Everyone tells. There is an experiment sitting in the physics literature that a great many people believe proves the future can reach backward and change the past. It is not a thought experiment. It was built, it was run, it was published, and the data are not in dispute. And for 25 years the story told about it has been wrong, in a way that is stranger and more interesting than the story itself. Here is the claim, in the form you have almost certainly encountered it. You send a particle toward a screen. Before it gets there, you secretly mark it, so that somewhere in the universe there now exists a record of which of two possible routes it took. The particle arrives, it lands, its position is written down, that part is finished, filed, over, and then, only afterward, a second decision is made somewhere else entirely about whether that record of the route will be read or destroyed. And when you go back and look at the pattern the particle already made, the pattern turns out to depend on the decision that had not been made yet. Read the record, and the particle behaved like something that took one route. Destroy the record, and the particle behaved like something that took both. The behavior came first, the decision came second. Therefore, the story concludes, the decision reached back through time and changed what had already happened. That is the delayed choice quantum eraser, and it lives everywhere. It lives in documentaries with slow strings underneath it. It lives in books written for general readers by people with impeccable credentials. It lives in an enormous quantity of online explanation, some of it excellent and some of it not, and it has been repeated so many times and with such confidence that it has become one of those facts that everyone knows. It also, and this is the part worth being honest about right at the start, lives in the original phrasing of some of the physicists who built these experiments. The published language talks about the delayed determination of whether a particle behaved as a wave or as a particle. To a specialist, that sentence means something quite specific and quite harmless. To everyone else on Earth, it reads like a confession that the past is negotiable. I want to be very clear about what is being questioned tonight and what is not, because this is the kind of topic where that line gets blurry fast, and the blur is where all the nonsense lives. The experiment happened. The apparatus was real. The results were published in a serious journal. They have been reproduced in laboratories on several continents, and every number in them holds up. Nobody in this story is lying. Nobody is hiding anything, and there is no suppressed finding waiting in a drawer. What is being questioned is one thing only, and it is the thing that never appears in the data at all. It is the interpretation. It is the story we drape over the numbers afterward to make them mean something, and the gap between what was measured and what was read into it is, in this case, wide enough to walk through. You should also know why this particular misreading spreads the way it does, because it is not really a physics claim when people repeat it. Think about what it would mean if it were true. Everything you have ever done is, as far as you can tell, finished. That is the one thing you can say about the past that you cannot say about anything else. The future is open and terrifying and full of things you have not decided yet, and the present is a thin moving sliver that you never quite get hold of, but the past is done. It has the enormous and underappreciated virtue of holding still. Every regret you carry is at least a regret about something settled. Every good thing that happened to you is safe in the sense that it happened, and nothing can reach in and unhappen it. Now imagine being told, by a laser and two slits and a crystal on an optical table in a laboratory in Maryland, that this is not quite right. That the settledness of the past is a convenience rather than a law. that there is a loophole, and someone found it, and it is small and technical and involves photons. But it is there, and if it is there at all, then the wall you have been leaning against your whole life has a door in it. That is why this story travels. It is not really about photons. I should tell you something before we go any further, because it changes the shape of the next 2 hours and because it is true. I have said the sentence out loud. I have said that the future changed the past, and I said it with a straight face, and I believed it when I said it, and I was wrong. I am not standing outside this one pointing at other people's mistakes. There is a whole generation of us who found this experiment, found the retrocausal reading of it, felt the floor tilt, and passed it along in good faith. Some of the people who explained this a decade ago have since gone back and said, plainly and publicly, that they got it wrong. That is a rare and admirable thing to do, and it is worth saying that it happened. So here is what tonight is. We are going to build the paradox properly from the beginning, and we are going to build it at full strength. I am not going to soften it or wave at it or tell you in advance that it is fine. We are going to walk through a thought experiment from 1978 that first put the idea on the table, and a proposal from 1982 that gave it its unfortunate name, and then the actual apparatus that was built and run and published on the 3rd of January 2000. And by the time we get to the results, I want you to feel the same thing the people who first saw them felt. Because if you do not feel it, the rest of this is just someone telling you not to worry about something you were not worried about. And then, in the second half, we're going to take it apart, not with new physics, not with a rival theory or a hidden assumption or a clever philosophical move that only works if you squint. We are going to take it apart with a piece of arithmetic so small that you will be slightly annoyed by it, and with a fact that is printed in the original paper, plotted in the original figures, and left out of essentially every retelling for the simple reason that it is not exciting enough to survive editing. There is one more thing I have to tell you, and then I will stop making promises and start keeping them. The answer to the question is no. The future does not change the past. Nothing reaches backward, and this is not the relief it sounds like, because when you take the retrocausal story away, something is left standing in its place, and the thing left standing is worse. It is worse in a specific and describable way that I think is genuinely one of the most unsettling facts in physics, and almost nobody talks about it because everyone is too busy arguing about time travel to notice what is standing right behind it. The retrocausal story, for all its strangeness, is at least a story. It has an actor. It has a direction. It has a mechanism and a moment of contact, a point at which one thing reached out and touched another thing. You can picture it. You can draw it on a napkin. What is actually there has none of those things, and it is enforced perfectly anyway, without exception, in every laboratory that has ever looked. So the question for tonight is not the one on the label. The question on the label is whether a measurement made later can change something that already happened, and we will answer that one carefully and completely. But underneath it there is a second question that the first one has been hiding, and it is the one that will still be standing when we are finished. What exactly did you think was there in the past waiting to be changed? Start with the thing everyone thinks they already understand. Part 2. The Only Mystery. Richard Feynman said of the double-slit experiment that it has in it the heart of quantum mechanics, and that in reality it contains the only mystery. He was not being modest on behalf of his field. He meant it as a technical claim. Everything strange that quantum mechanics does to your intuition, every paradox and every argument that has run for a century without resolution, is present in that one arrangement of a light source, a barrier with 2 narrow openings, and a screen behind it. You know the shape of it. Send something small at a barrier with 2 slits cut in it, and let it land on a screen. If you do nothing to find out which slit it went through, the landing positions build up into a pattern of bright and dark bands, an interference pattern, the signature of a wave that passed through both openings at once and overlapped with itself on the far side. Crest meets crest and you get a bright band. Crest meets trough and they cancel and you get darkness. This is not controversial when you do it with water or with sound. What makes it the only mystery is that it happens with things that arrive one at a time, as single indivisible events. That is the part worth pausing on for a moment, because it is easy to say quickly and hard to actually absorb. Turn the source down until it is emitting one particle at a time, so far apart that there is never more than one in the apparatus. Each one arrives at the screen as a single dot, a point. There is no smear, no fuzz, no partial arrival, And yet if you leave the thing running for a few hours and let the dots accumulate, the bands assemble themselves out of the dots. Nothing interfered with anything else, because nothing else was ever there. Each particle interfered with itself, and it is not fragile. It is not something that only happens to the smallest and most delicate things we can find. Interference of this kind has been demonstrated with electrons, with neutrons, with whole atoms, with molecules of 60 carbon atoms, and by the end of the 2010s with molecules built from more than 2,000 atoms, objects heavy enough that you can almost think of them as tiny pieces of matter rather than as abstractions. Nobody has ever found the size at which it stops. There is no known wall. The standard way to talk about this is superposition. Before the particle is detected, it is not sitting on one root or the other. The mathematics that describes it spreads through both openings and out the other side, and every possible path it could take to every possible landing point is present in that description at once. The pattern of bands on the screen is the shadow those overlapping possibilities cast. It is what the world looks like when several versions of a journey are all still on the table. One useful way to picture it, and one I will come back to, is as a tree of possibilities growing outward from the moment the particle leaves the source. Every branch is a route it could take. The pattern on the screen is not the record of one branch, it is the sum of all of them, interfering, some reinforcing and some cancelling, and what you see is the shape of the whole tree pressed flat against a wall, and you can prune that. This is the crucial move, the one everything else in tonight's story is built on top of. If you interfere with the process early enough, if you cut down the number of possibilities before the particle reaches the screen, the final distribution of landing points reflects the pruning. Put a detector at one of the slits, something that registers whether the particle passed through it without stopping it, and the interference bands go away. You collapse the description early. You force the question of which route at the slits rather than letting it stay open until the screen. Now this channel has spent a lot of time inside that experiment, and I am not going to walk you through the whole history of it again tonight, because we have somewhere else to be. What I want instead is one specific question, and I want you to hold on to it, because it is going to turn out to be the hinge that the entire second half of this video swings on. The question is this: when you make that measurement at the slits, when you find out which route the particle took and the interference bands go away, what exactly do you have on the screen instead? I want to be precise about what I am asking. I am not asking what the mathematics does, and I am not asking what it means philosophically, and I am not asking whether the particle is a wave or a thing. I am asking a completely concrete question about a pattern of light or a pattern of dots on a surface, the kind of question you could answer by taking a photograph and looking at it. Which slit did it go through? We now know. So what is on the wall? Almost everyone gets this wrong. Not slightly wrong, not wrong in a technical detail that only matters to specialists. Wrong in the sense of confidently describing a pattern that has never once been produced by any version of this experiment, ever, anywhere. And the wrong answer is so widespread and so intuitive and so satisfying that it appears in textbooks written for general readers, in lecture demonstrations, in animations, and in the diagram that is probably in your head right now. I know it is in your head right now because it was in mine for years. And here is why it matters, why I am spending time on what looks like a footnote before we have even reached the experiment we came here for. Everything that is about to happen in this story, the whole apparent miracle, the entire reason people believe the past got edited, rests on this one picture being right. Get this picture wrong, and what happens later is genuinely impossible, and you will have no choice but to reach for something exotic to explain it. Get it right, and the miracle does not survive the first 10 minutes of the second half. So let us go and look at what is actually on the wall. Part 3. The blob. The answer everyone gives is 2 clumps. 2 neat piles of landing points, one behind each slit, exactly what you would get if you fired tiny solid balls through 2 holes in a fence. The reasoning behind that answer is airtight and completely sensible. If we now know that each particle went through one slit and not the other, then each particle behaved like a little object taking one route, and little objects taking one route make a pile behind the opening they went through. 2 openings, 2 piles. The wave behavior stopped. The particle behavior started. Observation turned one into the other. That has never happened. Not in any laboratory, not in any version of this experiment, not once in more than a century of running it. The 2 clumps are a ghost. They are the most confidently drawn diagram in popular physics, and they correspond to nothing anyone has ever produced. What you actually get is a single slit diffraction pattern. A broad bright band in the middle, then a dark gap, then a fainter band, then another dark gap, then a fainter band still fading out toward the edges, which is to say, bands, which is to say, interference, which is to say that the thing you just measured, the thing you just caught in the act of going through one specific opening, is still behaving like a wave and is still interfering with itself and never stopped for a second. Let me put you in front of it, because this is one of those cases where a diagram does you a disservice, and the actual visual experience is what makes it land. You're standing in a dark room. There is a wall in front of you and a faint red pattern on it, thrown there by a laser that is running behind you, through a barrier with 2 hairline slits cut into it. What you see is a ladder, a dense stack of bright vertical bars separated by clean black gaps, so many of them, and so tightly packed that toward the edges of the field they begin to blur together and you lose count. Each of those black gaps is a place where 2 waves arrived exactly out of step and destroyed one another completely. The darkness is not the absence of light. The darkness is light plus light equaling nothing. Stand there long enough, and the strangeness of that sentence starts to work on you. There is a spot on that wall where, if you block one of the 2 slits, light appears. Block half the source, and the wall gets brighter. That is what an interference pattern is, and it is the reason a barrier with 2 openings was enough, more than 200 years ago, to overturn Isaac Newton's conviction that light was a stream of tiny corpuscles, and to convince physics that it was a wave instead. The pattern you are looking at settled an argument that had run for a century. Now something goes into the apparatus that marks which slit each photon came through. You do not have to know how yet. The pattern on the wall changes, and here is what it does not do. It does not snap into 2 bright rectangles, it does not become 2 piles, it does not become anything hard-edged or solid at all. What it does is relax. It is a slow and almost gentle change, and if you were not watching for it, you might describe it as the pattern getting tired. The many fine rungs of the ladder slide toward each other and smooth out, and what settles onto the wall is one broad soft glow in the middle, with 2 or 3 much wider, much fainter bands trailing away to either side, and dark gaps between those. The pattern got simpler. It got wider. It did not stop being a pattern. And that is the whole thing. The stripes did not die. The stripes got wider. The reason is not mysterious, and it is not even quantum mechanical. It is ordinary optics, and it was in textbooks before anyone had heard of a photon. A wave forced through a single narrow gap spreads out on the far side, and different parts of the wavefront emerging from different points across the width of that one gap travel slightly different distances to any given spot on the wall, and so they arrive slightly out of step, and so they interfere. One slit is enough. The edges of a single opening are enough. This is called Fraunhofer diffraction, and it is why the shadow of a hair in a laser beam has fringes in it, and why a distant streetlight through a mesh curtain blooms into a cross. You have been looking at single-slit diffraction your whole life without a name for it. Squint at a bright point of light at night, and the little spikes that appear around it are the edges of your own eyelashes doing exactly this. So the 2 patterns are cousins, not opposites. Put them side by side and the family resemblance is obvious. Both have a bright centre, both have dark fringes. The double-slit version simply has far more of them, packed far more tightly. The single-slit version has a wide central lobe and only a handful of faint companions. The relationship between the 2 is a piece of arithmetic that runs backwards from your intuition. Wider spacing in the pattern comes from narrower structure in the source, and narrower spacing in the pattern comes from wider structure in the source. 2 slits set some distance apart are, in the relevant sense, a wider structure than one slit is on its own, and so they produce the finer stripes. Here is why the eye gets fooled. If you have been told to look for the disappearance of interference, and what appears is a smooth broad glow with a couple of faint bands you are not paying attention to, your brain files it as nothing, as blank, as the absence of the thing. It looks featureless because you are comparing it to a ladder with 40 rungs, not because it is featureless. The single slit pattern is a lot of things, but it is not the absence of interference. There is a second reason this correction matters, and it matters more than fixing a diagram. If measurement flipped particles between 2 modes, wave mode and bullet mode, then there would have to be a switch somewhere, a threshold, a point at which quantum behavior ends and ordinary behavior begins. There is no such switch. What there is instead is a smooth trade. The more precisely you know which route a particle took, the fainter its interference fringes become, and the relationship between those two quantities is continuous. You can build an apparatus that gives you partial route information, a hint rather than an answer, and you get partial fringes, washed out but still visible. You can sit anywhere you like on that curve. Physicists have built experiments that deliberately park in the middle of it, and nothing dramatic happens there at all. There is no line being crossed. There is a dial. Physicists wrote that dial down as an inequality in the middle of the 1990s, and it is one of the quietly important results in the whole field, because it takes a philosophical argument about complementarity, an argument that had been conducted in words since the 1920s, and converts it into a number you can measure. The visibility of your fringes and the distinguishability of your roots are two quantities, and the sum of their squares can never exceed 1. That is it. That is the whole rule. You may have perfect fringes and no idea of the root, or perfect root knowledge and no fringes or anything in between, and the inequality tells you exactly what the exchange rate is at every point along the way, and the marker does not have to touch the particle to move you along that dial. This is worth flagging now because it is going to become the entire subject of a later part of this story. The old comfortable explanation for why fringes disappear was mechanical. To detect something you have to interact with it. Interaction means a kick. Kicks are random. Random kicks smear a pattern. It is a very reassuring explanation because there is nothing quantum about it at all. It is also, as we'll see, not the reason. And there is one more detail which I want to plant carefully, because we are going to need it later, and it will not look important when I say it. Go and find a real photograph of a real double-slit interference pattern, one taken from an actual experiment rather than drawn for a textbook. Look at the fringes near the edges. They fade. They get dimmer the further out you go, and there is an overall shape to the brightness, a broad hump rising to a peak in the middle and falling away at the sides, with the fine stripes riding on top of it. That overall shape is the single-slit pattern. It was there the entire time. It is called the envelope, and it comes from the width of each individual opening, which does not go away just because there are two of them. So when you make a witch root measurement, you are not adding a new pattern. You are removing the fine structure from inside a shape that was already present and had been present since the first photon landed. I am going to give this thing a name so that we can find it again later. From here on, when the fine stripes go away and you're left with that broad soft glow, I am going to call it the blob. It is not a technical term. It is the least interesting object in tonight's story, the thing that shows up when nothing exciting is happening, the shrug of the experiment. Remember it anyway, because now we can go and find out what happens when somebody decides to make that measurement late. Part 4. The decision that came too late. In 1978, at a symposium held in honour of Richard Feynman, a physicist named John Archibald Wheeler stood up and proposed something that has been causing arguments ever since. Wheeler is a name worth knowing if you do not already. He is the man who gave us the term black hole, and wormhole, and quantum foam. He supervised Feynman's doctoral work. He spent the last third of his career on questions that most of his colleagues considered slightly embarrassing. Questions about what a measurement actually is, and whether the universe requires observers in some structural sense. And he asked them with such precision and such obvious seriousness that people had to take them seriously too. His question that day was simple enough to state in one sentence. In the standard account of quantum mechanics, the experimenter's choice of apparatus determines what sort of behaviour appears. Build a machine that asks which route, and you see route taking. Build a machine that asks about interference, and you see wave behaviour. Fine. Everybody accepts that. But what if you wait? Wheeler's version used an interferometer rather than two slits, which is the same idea in a different housing. Light comes in and hits a half-silvered mirror that splits it into two beams travelling along two separate arms. The arms are steered back together by ordinary mirrors, and then, at the meeting point, you have a choice. Put a second half-silvered mirror there, and the two beams recombine and interfere, and what you measure is a wave phenomenon that required both arms. Leave that second mirror out, and the two beams simply cross and continue on to two separate detectors, and which detector fires tells you unambiguously which arm the light travelled down. Now, the twist. Do not decide about that second mirror until the light is already inside the machine. Let the photon enter, let it pass the first mirror, let it get well down the arms, past any point at which it could still be described as making up its mind about what kind of thing to be. Then, at the last possible instant, slam the second mirror into place or yank it out. What happens is that the result always matches the apparatus. Every time. The photon is never caught out. You never get a photon behaving like a root taker in an interference measurement, or like a wave in a root measurement, no matter how late the apparatus was configured, no matter how obviously it had already committed. It is as though the photon knew what you were going to do. For 30 years this was a thought experiment, which is a polite way of saying that nobody could build it, because slamming a mirror into a beam path faster than light can cross a laboratory bench is not a trivial engineering problem. It was done properly in 2007. The photons came from a colour centre in diamond, a single nitrogen atom sitting where a carbon atom should be, which can be persuaded to emit exactly one photon at a time and no more, so there is no possibility of one photon sneaking down one arm while a second sneaks down the other. The choice of configuration was made by a quantum random number generator, while the photon was already inside the interferometer, and the whole switching arrangement was fast enough and far enough apart that no signal travelling at light speed could have carried news of the decision back to the entrance in time to matter. The interference, when interference was called for, came out at around 94% visibility. Wheeler's prediction held exactly, and it held with no retrocausality anywhere in the analysis. Wheeler was not content to leave it at the scale of an optical bench, and the version he supplied next is the one that people remember. Take a quasar, one of those extraordinarily luminous objects at the centres of distant young galaxies, so far away that its light has been travelling toward us for billions of years. Now put a massive galaxy between that quasar and Earth, positioned so that its gravity bends the quasar's light around both sides of it, the way a lens bends light around its own middle. This is not hypothetical. Gravitational lensing is observed routinely, and there are catalogues of these objects. The first one was identified in 1979, a single quasar appearing as two images on either side of an intervening galaxy, and hundreds more have been found since. What you have built, without anyone building it, is an interferometer the size of the observable universe. Two routes, two paths the light could have taken around the intervening galaxy, separated by an arrangement so large that the difference in travel time between them can run to years. The light took those routes, or that route, before the Earth existed, before the Sun existed. It has been in flight since a time when the material that would eventually become the planet you are lying on was still dispersed through a cloud that had not yet begun to collapse. And tonight, an astronomer at a telescope decides how to measure it, combine the two paths and look for interference, or keep them separate and see which side it came around. Sit with the image, because it is the emotional heart of the entire retrocausal claim, and it deserves to be felt rather than summarized. There is a person on a mountain in the dark, cold, tired, on an entirely ordinary night, making an entirely ordinary technical decision about the configuration of an instrument, and the decision appears to determine something that happened before there was an Earth to make decisions on, not to reveal it, to determine it. A hand reaching back across a distance of time that has no human meaning at all, and touching something. That image is the reason this story is unkillable, and here is the part that essentially never gets attached to it. Wheeler thought that reading was flatly, unambiguously wrong, and he said so, repeatedly, for the rest of his life. He described the idea that a present decision affects a past event as an unfortunate way of putting it. He was not hedging or being diplomatic. His position was that the entire framing contains a smuggled assumption, and the assumption is the problem. The assumption is that there was a route, that somewhere back there, in the past, sitting quietly in the dark for billions of years, was a fact about which way the light went, waiting to be either discovered or altered. Wheeler denied that. His formulation, which he repeated in various shapes across decades, was that no elementary phenomenon is a phenomenon until it is a registered phenomenon. Until something happens that leaves a record, there is no event. There is nothing there, and you cannot change a thing that is not there. He built an entire program on this. He called it the participatory universe, and he summarized it in a phrase that has outlived most of the physics of its era. The idea that existence comes from information, that the furniture of the world is assembled out of the answers to yes or no questions. And his favourite way of explaining what he meant was a parlour game. You play 20 questions, except the group agrees secretly, without telling the questioner, not to pick an object at all. They simply agree to answer each question in a way consistent with every answer they have already given. The questioner asks, the answers accumulate, the possibilities narrow, and at the end there is an object. It is a real object. It is determined by the answers. and it was not there before the questions began, and nobody in the room chose it. Wheeler thought that was not a joke about parlour games. He thought it was a serious model of what a measurement is, and this was not an idle late-career eccentricity, whatever his colleagues occasionally muttered. The same instinct has since been pushed to a scale Wheeler would have enjoyed enormously. In the 2010s, experimenters ran tests in which the settings of their measuring apparatus were determined not by a random number generator in the room, but by the colour of light arriving from distant quasars, so that whatever fixed those settings was fixed billions of years before the experiment existed. The point of those experiments was to close a loophole about whether the choices were truly free. The side effect was a delayed choice experiment on the largest stage available. So the retrocausal reading of the delayed choice experiment was rejected by the person who invented the delayed choice experiment in public on the day he invented it and consistently for 30 years afterward. That is the first crack in the story we came here to examine, and I want to be honest that it is not enough on its own. Wheeler's answer is a philosophical position, elegant and probably correct, but it is a position rather than a demonstration. He tells you that there was nothing there to change. He does not show you, on paper, with numbers, why the experiment produces the pattern it produces. Somebody else was about to supply the machinery that makes the puzzle sharp enough to require that answer, and they were going to give it a name that has been doing damage ever since. Part 5. Information, not force. 4 years later, in 1982, two physicists named Marlon Scully and Kai Druhl published a proposal in Physical Review A that took aim at something everyone thought they already understood. The target was the explanation people gave for why witch-root measurements kill interference. That explanation was mechanical, and it went like this. To find out which slit something went through, you have to interact with it. You have to bounce something off it, or absorb something from it, or push on it in some way, because that is what detection means. And any such interaction gives the particle a small random shove. The shoves are unpredictable in size and direction. Accumulate enough of them over enough particles, and the fine structure of an interference pattern gets smeared into mush. Mystery solved. You can see why that explanation was popular. There is nothing quantum about it. It is the same reason a photograph of a moving car comes out blurry, or the reason you cannot measure the exact position of a floating dust mote by poking it. Detection disturbs, disturbance blurs, move along. There was even a famous argument along these lines between Niels Bohr and Albert Einstein in the 1920s and 30s, in which Einstein kept proposing ingenious ways to detect a particle's route without disturbing it, and Bohr kept finding the disturbance Einstein had overlooked, sometimes by invoking Einstein's own theory of gravity against him. Bohr won those exchanges, but he won them by locating a disturbance every time, which quietly cemented the idea that disturbance was the reason. It was the right answer to the wrong question, and it took another 50 years for anyone to notice. Scully and Druhl asked what would happen if you removed the disturbance entirely and kept only the knowledge. Their proposal was to store the root information not by hitting the particle from outside, but in something the particle already carries with it. An atom, for instance, has internal states, configurations of its own electrons that have nothing to do with where it is or how fast it is moving. Arrange things so that passing through the left opening leaves the atom in one internal state, and passing through the right opening leaves it in another, and you have written down which route it took without giving it any push worth mentioning. Its momentum is essentially untouched. Its trajectory is essentially untouched. Nothing was jostled. And a record now exists. Not a record in a filing cabinet somewhere. A record woven into the particle itself, riding along inside it, in a property that has no bearing on where it is going. The prediction was that the interference would die anyway. It does. This has been confirmed many times over, in many different physical systems, and it is one of the genuinely disquieting facts about the universe that survives everything else we're going to do to this story tonight. The fringes are not destroyed by force, they are destroyed by the existence of information. Somewhere in the world there is now a thing that could in principle be interrogated to reveal the root, and that is sufficient. The pattern does not wait to see whether anyone will actually interrogate it. Push on that a little, because it gets worse. You do not have to read the record. You do not have to intend to read the record. You can take the marker, whatever it is, and throw it away. Send it down a fibre into a detector nobody is watching, or into a wall, or out of a window. Never look at it. Never store the result. Arrange matters so that the information is scattered irrecoverably into the environment within a nanosecond of being created. the fringes stay gone. Nobody learned anything, no mind was involved at any point in the process, and the pattern still knows. I want to be careful here, because this is precisely the place where a lot of popular physics goes off a cliff and starts talking about consciousness creating reality. That is not what is happening, and we will come back to it properly later. The word observer, in this business, has never meant a mind. It means any interaction that leaves a record capable of distinguishing the roots. A crystal counts, a stray air molecule counts. The universe is not checking whether anyone is home, but the honest version of the fact is still strange, and I do not want to smooth it away in the process of correcting the misreading. The pattern depends on whether the information exists, not on whether it is used. There is a useful way to hold that without going mad. Think of interference not as something a particle does, but as something the world permits when two possibilities remain genuinely indistinguishable. The moment anything anywhere makes them distinguishable in principle, the permission is withdrawn, whether or not the distinction is ever actually drawn. It is less like being watched, and more like a rule about bookkeeping. Two entries can only cancel if they are entries of the same kind. Give them different labels and they stop cancelling, and it does not matter whether an accountant ever opens the ledger. Then came the second half of the Scully and Drull proposal, and this is where the trouble starts. If the interference vanished because a record exists, they reasoned, then what happens if you take that record and put it into a form where it no longer distinguishes the two roots? Not delete it. You cannot delete quantum information. The mathematics that governs how quantum systems evolve is reversible, which means information can be moved around and re-encoded and hidden and scrambled, but never actually removed from the world. There is a companion result that says you cannot copy it either. So deletion is off the table in both directions, but you can transform it. You can measure the marker in a different way, ask it a different question, one whose answer is compatible with either root and therefore tells you nothing about which. Do that, they predicted, and the interference comes back, and they called it erasing the which-way information. That name has probably done more damage to public understanding than any other four words in modern physics. Erasing sounds like removal. It sounds like a thing was in the world, and then it was taken out of the world. It invites you to picture a hand going back and rubbing out a pencil mark, which is exactly the mental image that makes the later experiment look like time travel. Nothing is ever erased. Nothing is ever removed. What happens is a rotation, a change of basis, a decision to ask a question the record cannot answer. The information is still sitting right there, in full, undiminished. It has simply been asked something else. I keep coming back to the word because I think it is genuinely responsible for a substantial share of the confusion in this field. A published critique of the whole business puts the objection right in its title, arguing that the delayed choice quantum eraser neither erases nor delays. Two words, both wrong, both load-bearing. Hold on to that, because when we get to the famous experiment, the entire apparent miracle is going to be riding on the connotations of a badly chosen verb. The laboratory versions followed through the 1990s. A widely cited photon experiment in 1995 demonstrated the trade between root knowledge and interference using correlated pairs and an interferometer. Erasure has since been shown with neutrons, with atoms, with nuclear spins inside molecules, and in undergraduate teaching laboratories using equipment that cost a small fraction of what the original apparatus did. That last detail matters more than it sounds. When an effect migrates from a specialist laboratory into a teaching laboratory, it has stopped being a frontier result and become a demonstration, something you set up on a Tuesday so that students can see it work. Quantum erasure crossed that line years ago. Whatever is happening here, it is not rare, it is not delicate, and it is not in doubt. The one I want you to have in mind, though, was published in 2002, because it is the closest relative of something we're going to build ourselves later tonight. It used an actual young double slit, the real thing, 2 openings in a barrier. In front of each opening, the experimenters placed a quarter-wave plate, a thin piece of optical material that alters the polarization of light passing through it. The 2 plates were oriented at right angles to each other, so that light coming out of one slit ended up with one circular polarization, and light coming out of the other ended up with the opposite one. Polarization is the marker. It travels with the light. It requires no jostling, no detector at the slits, no interaction of any kind beyond the light passing through a piece of glass. The fringes vanished. And then, by measuring the polarization of the other photon of an entangled pair, in a rotated basis, the experimenters brought the fringes back. but only in the sorted subsets. I said that last sentence quickly, and I'm going to leave it there for now, because it is the entire resolution of everything, and you're not ready for it yet. What you are ready for is the machine. Part 6. 8. Nanoseconds. The experiment that everybody argues about was built at the University of Maryland, Baltimore County, by 5 people: Yoonho Kim, Rong Yu, Sergei Kulik, Yanhua Shi, and Marlon Scully, who was the same Scully from the proposal 18 years earlier. It takes a certain kind of patience to spend 18 years between having an idea and watching somebody's laser actually do it. It was published in Physical Review Letters in Volume 84, starting on page 1 on the 3rd of January 2000. Page 1 of Volume 84 means it was the first paper in the volume, which means it opened the year and, as it happens, opened the millennium. If you were designing a piece of physics folklore from scratch, you could not do better than that. The title of the paper is worth reading carefully because the authors put quotation marks around one of the words. It is called a delayed choice quantum eraser, with the word choice in scare quotes. Those quotation marks are not decorative. They are the authors telling you, in the title, before you have read a single line, that nobody chooses anything. No experimenter is standing there deciding whether to erase. The decision is made by a photon hitting a piece of half-silvered glass, which is to say by nothing at all, which is to say by chance. Almost every retelling of this experiment drops the quotation marks, and with them the disclaimer. Let me walk you through the machine, because it is not complicated, and because you cannot follow the argument without it. You start with a laser aimed at a barrier with 2 slits, exactly as before. Nothing exotic yet. Behind each slit, though, sits a small crystal of a material called beta-barium baryta, and this crystal is where the trick lives. When light passes through it, very occasionally, a single photon is converted into 2 photons, 2 out of 1. They come out with roughly half the energy each, which means roughly twice the wavelength, and they come out quantum mechanically entangled with each other, which in this context means something very specific. They carry the same information about where they came from. If the parent photon came through the upper slit, both daughters carry the upper slit stamp. If it came through the lower slit, both daughters carry the lower. The root information has been copied into a second particle, without anyone having to detect the first one, without a shove, without an interaction at the slits at all. This is the machinery Scully and Druhl proposed, built out of optics rather than atoms. The process has a name that is longer than it needs to be: spontaneous parametric down conversion. Spontaneous because nobody triggers it, parametric because energy is conserved between the parent and the 2 daughters, down conversion because the children come out at lower energy than the parent. It is also almost unbelievably inefficient. In a typical crystal, something like 1 photon in 100 billion actually splits. The rest go straight through, untouched, and are dumped. That is why these experiments run for hours and produce their results as accumulated counts, rather than as an image. You're not looking at a beam, you are fishing. The crystal itself is birefringent, meaning light travels through it at different speeds depending on its polarization, and that property is what lets experimenters tune the geometry so the twins emerge in well-defined directions with well-defined polarizations. Without that control, the pairs would spray everywhere and be useless. Now the 2 daughters part company, and this is where the geometry starts doing the work. One of them, conventionally called the signal photon, takes a short trip to a detector. This detector is not a screen in the sense you are picturing. There is no photographic plate, no phosphor, nothing you could photograph. It is a single small photon counter mounted on a motorized stage, and over the course of a run it is stepped across the plane where the pattern would form, sitting at each position for a while and counting how many photons arrive there. The pattern, when you finally see it, is a graph. It is assembled position by position, over hours, out of counting statistics. Nobody in that room ever sees stripes on a wall, they see a spreadsheet. The other daughter, called the idler, is sent off on a much longer journey. It goes through prisms, off mirrors, and eventually into an arrangement of 4 separate detectors. 2 of those 4 are what you might call the tattletales. There is a clean, unambiguous path from the upper slit to one of them, and from the lower slit to the other, so if either fires, you know exactly which slit the parent came through. The other 2 detectors sit behind a beam splitter that takes the 2 possible routes and recombines them before they arrive. If one of those 2 fires, the photon could have come from either slit, and there is no way even in principle to tell. Those are the erasers. Which of the four a given idler ends up at is not chosen by anyone. It arrives at a beam splitter and takes one branch or the other, and that is that. Photon by photon, the machine flips a coin. Now the delay, which is the whole reason this experiment has the name it has. The idler's path through all that optical hardware is roughly 2.5 meters longer than the signal's short hop to its counter. Light covers 2.5 meters in about 8 nanoseconds, 8 billionths of a second. So for every single pair, the sequence is this. The signal photon arrives at its counter, it is detected, its position is recorded and written to a file on a computer, and that photon no longer exists. And then, 8 nanoseconds later, its twin reaches the beam splitter where the fate of the route information gets decided. The record of where the first one landed is already sitting on a hard drive before the coin flip that determines whether the route will be revealed or scrambled. Which one went first is not in dispute. The signal went first. That is a fact about lengths of optical fibre, and the length is a design choice rather than a limit. Later variants of this experiment have stretched the idler's path considerably further, and the outcome does not change with the length of the delay. Nobody has ever found a delay long enough to break it or short enough to make it stop working. That, on its own, ought to be a small clue that the delay is not doing any physical work. But we are not there yet, and I want you to arrive at that on your own rather than take it from me. Let me put you in that room for a minute, because the physical reality of it is nothing like the way it gets animated. The lights are off. There is an optical table in the middle of the floor, a slab of steel about the size of a dining table, drilled with a grid of threaded holes and floating on legs full of compressed air, so that footsteps in the corridor outside do not shake the beam by a wavelength. Everything is bolted to it. There is a hum from the laser's cooling. The detectors are photon counters, and photon counters click. They put out an audible pulse for every event, and on a good run with everything aligned, a room like this sounds like faint rain on a window. A photon leaves the laser. It meets the barrier and the two slits. Behind one of them, in a crystal a few millimeters across, it becomes twins. One twin flies about 0.5 meter and dies against a moving detector, and a number appears in a column on a screen. 8 nanoseconds later, a length of time in which light could cross this room, and most of the next one, the other twin reaches a half-silvered mirror and goes one way rather than the other for no reason whatsoever. Its brother has been dead for 8 billionths of a second. The decision that supposedly governed how that brother behaved has just been made, in the dark, by an inanimate piece of glass with nobody watching. Nobody in the room notices anything. The rain keeps falling. I want to be honest about the scale, because the honesty cost me some drama, and the video is better for it. The delay is 8 nanoseconds. The distance is 2.5 meters of extra path. Every retelling I have ever encountered invites you to imagine a decision made days or months or years later, and that is not what happened here. In principle, it should not matter. If a nanosecond of backwards influence is possible, then a century is possible, and the argument does not care about the magnitude. But if you are picturing a physicist in 2026 making a decision that reaches back and alters a photograph taken in the 1990s, you are picturing something the experiment did not do. One last piece of vocabulary before we look at what came out, and I am going to introduce it as neutrally as I can, because in about half an hour it is going to turn out to be the most important thing in this entire story, and I do not want to tip my hand. You cannot make sense of any of these events on their own. Detectors fire for all sorts of reasons. Thermal noise, cosmic rays, stray light that got past the baffles. To know that a particular signal detection and a particular idler detection came from the same original pair, the apparatus records the time of every event and keeps only those pairs that fall within a very narrow window of each other, a few nanoseconds wide. This is called coincidence counting. It is completely standard, it is entirely necessary, and without it the whole experiment produces nothing but static. There is one more thing about coincidence counting that I will say now and then leave alone, because it will sound trivial and it is not. The signal detector and the 4 idler detectors are at opposite ends of the apparatus. Their outputs are 2 separate streams of numbers in 2 separate files. Nothing about the signal file knows anything about the idler file. For the two to be compared, somebody has to physically bring them together. Remember that somebody has to do that. Nothing else in tonight's story is going to matter as much. The machine is built. Let us see what it said. Part 7. The 4 curves. The result of the experiment is 4 graphs. Each one has the same axes. Along the bottom is the position of the signal detector, the little counter on its motorized stage, stepping across the plane where the pattern should form. Up the side is the number of coincidences recorded at that position, which is to say the number of times the signal photon landed there and a particular one of the 4 idler detectors fired within the timing window. 4 idler detectors, 4 graphs. Look at the 2 graphs belonging to the tattletale detectors first, the ones where the idler's arrival tells you unambiguously which slit the parent went through. Those 2 graphs are smooth humps, a broad rise, a peak, a fall, no stripes, no bands, nothing periodic at all. And by now you know exactly what that shape is, and you know not to call it nothing. That is the blob. That is the single slit envelope. It is a wave that went through one opening and spread. So far, so unremarkable. The root information exists, it is readable, and the fine interference structure is absent. This is the textbook result, and nobody would have written a paper about it. It is the same shape you would get by covering one slit entirely, and in a sense that is what has happened. The root information has committed each photon to one opening, and one opening produces one opening's pattern. Now look at the other 2, the ones belonging to the erasers, where the 2 possible roots were recombined at a beam splitter before the idler arrived, so that a firing tells you nothing about which slit anything came from. Both of those graphs have interference fringes in them, clean ones, peaks and valleys, regular, unmistakable, marching across the plot. The pattern that is supposed to be impossible once root information has been created is sitting right there in the data, twice. And now put the timing back into it, because the timing is the entire reason we are here. The signal photons that produced those fringes had already arrived. They had already been counted. Their positions were already recorded in a file, 8 nanoseconds before their twins reached the beam splitter that sent them toward an erasing detector rather than a revealing one. The stripes in that graph were made by photons that were finished before anything was decided. I want to be exact about what is being claimed, because vagueness at this point is where the mysticism gets in. Nobody is saying the fringes appeared on a screen and then rearranged themselves. Nobody is saying anyone watched a pattern change. The claim is narrower, and if anything, harder to answer, that a fixed body of already recorded data has a property, striped rather than smooth, which correlates perfectly with something that had not occurred when the data was written. Correlation with a future event is not by itself forbidden, but there is no innocent mechanism on offer here, because the future event in question was decided by a genuinely random process, and random processes cannot be anticipated by anything. I am not going to soften this. I am going to give you the retrocausal reading at full strength, in the terms its believers use, because you cannot properly dismantle something you have only seen a caricature of. Here it is. The signal photon's behavior was fixed by a decision that had not happened yet. Not correlated with, fixed by. Because notice what the alternative would have to be. If the signal photon's behavior was already determined at the moment it landed, then it had to have been determined in a way that anticipated what the beam splitter would do 8 nanoseconds later. And the beam splitter's outcome was genuinely random, and there is no mechanism by which anything at the slits could have known it in advance. So either the future reached back, or the universe conspired in advance, and a conspiracy of that precision, running perfectly for millions of events, is not obviously less strange than a message travelling backwards. There is a third option, and I want to name it now even though it will sound like nothing. Perhaps the question is malformed. Perhaps there is no property of the signal photons that was ever either striped or smooth, and the whole argument is an argument about an object that does not exist. That is the answer, as it happens. It sounds like a dodge. It is not one, and by the end of tonight you will see exactly where the object goes missing. And this is not a fringe reading held only by people who did not understand the paper. It was, for a long time, the mainstream popular understanding, and it was arrived at honestly by people who read the paper carefully. The framing invited it. The authors themselves wrote about the delayed determination of whether the photon behaved as a wave or as a particle. And if you are not a specialist, that sentence has exactly one meaning. The presentation of 4 separate graphs naturally directs your attention to the 2 fringed ones, because those are the interesting ones. And the physics community has a long and well-documented habit of describing quantum results in language that is precise inside the field and catastrophically misleading outside it. Let me stop here and put the pieces on the table, because we are at the exact middle of this, and the second half is going to move fast. Here is everything we have established so far. Interference is what you get when two possibilities remain indistinguishable, and it happens to single particles, one at a time, which means each one interferes with itself. Measuring which route a particle took does not turn it into a bullet. It gives you the blob, a wide, smooth, single-slit pattern, which is still a wave and still interference, and just has fewer, wider stripes. Wheeler pointed out in 1978 that you can make the measurement choice after the particle has committed, and the particle is never caught out, and he insisted that the reason is that there was no committed fact in the first place. Scully and Druhl showed in 1982 that the interference dies from the mere existence of root information, with no mechanical disturbance required at all, and that you can rotate that information into a form that no longer distinguishes the roots and get the fringes back. And then in 2000, 5 people in Maryland built a machine that does exactly that, with the rotation happening 8 nanoseconds after the signal photon was already dead and recorded. And the fringes came back anyway. I want you to sit with what that would mean if it were true, and I do not want to rescue you from it yet. 8 nanoseconds is nothing. It is a length of time with no human meaning whatsoever. You cannot experience it. You cannot act inside it. It is a rounding error in the firing of a single neuron, and that is precisely why it lands so hard, rather than why it should be dismissed. Because the magnitude is not the point. If a decision made 8 billionths of a second late can reach back and adjust something that has already been written down, then the property you have been relying on your entire life, that what has already happened is finished, is not a law of nature. It is a habit of thought. It is something that is true of most things most of the time, at the scales you happen to live at, in the way that most tables are solid and most water is wet. A convenience of scale. A local approximation that the universe is under no obligation to honour. Think about what that does to the word past. Everything you carry is back there. Every conversation that went badly, every one that went well, the shape of a face you will not see again, the sequence of accidents that put you where you are tonight. All of it filed, all of it you assumed immune. The future can take things from you, but the past cannot be taken, because it already happened, and that is the one guarantee existence appears to offer without conditions. And notice how quickly the mind runs with it, once the door is open. If a decision can reach back 8 nanoseconds, then the number 8 is arbitrary, and the mechanism does not care about magnitudes, and so in principle, a decision can reach back an hour, a decade, a lifetime. If the amount of information is 1 bit, then the mechanism does not care about volumes either, and so in principle it is not 1 bit. Nobody who tells this story stops at photons. Within about 30 seconds of hearing it, most people have arrived somewhere near their own history, and are quietly wondering which parts of it are still in play. That leap is not stupid. It is exactly what the claim license is, if the claim is true, and a table in Maryland with a laser on it seems to be saying that the guarantee has an exception in it. A tiny one, 8 nanoseconds wide, involving photons, of no practical consequence to anyone, but an exception is an exception. A wall with 1 door in it is not a wall. That is what the story says, and for 25 years an enormous number of thoughtful people have believed it, and I was one of them. I have explained it that way. I have watched other people's faces do the thing your face is probably doing right now, and enjoyed it, and moved on without checking. Now. There is a fact in that paper that resolves all of this. It is not hidden. It is not disputed. It is not a subtle philosophical move, and it does not require any physics we have not already covered. It is printed in the original publication, plotted in the original figures, sitting in plain sight where anyone can look at it, and it has been left out of essentially every retelling of this experiment for one reason, and one reason only. It is boring. Part 8. A laser, a rock, and a dark room. Before we go back to Maryland, I want to build something. Everything we have looked at so far requires a crystal that costs more than a car, a room with the lights off, and photon counters that need to be cooled. That is a problem, not because the experiment is unavailable to us, but because when an argument can only be settled by equipment you will never touch, you are left taking somebody's word for it. And this particular argument does not need to be settled that way. There is a version of the delayed choice quantum eraser you can assemble from a laser pointer, a double slit, 2 small pieces of polarizing film, and 1 rock. I want to be precise about the word version, because it is doing real work. This is not an analogy in the loose sense of a helpful comparison. If you write down the mathematics that describes the original experiment, and you write down the mathematics that describes this one, They are the same expressions with a few of the labels changed. The structure is identical. That sounds like it ought to be impossible. One experiment involves entangled photon pairs generated in an exotic crystal and separated across an optical bench. The other involves a $2 filter and a piece of limestone. How can they be the same mathematics? The answer is one of the quietly astonishing facts about quantum mechanics, and it deserves a moment on its own. A quantum system with two distinguishable options is a quantum system with two distinguishable options, and the mathematics does not know or care what physically implements them. Which slit a photon went through, whether a photon is polarized horizontally or vertically, whether an electron's spin points up or down along some axis, whether an atom is in its ground state or an excited one. These are the same abstract object wearing 4 different costumes. Everything you can prove about one, you have proved about all of them. That is why a result discovered with atoms transfers to photons, and why a demonstration built with polarizing film reproduces one built with entangled pairs. The universe appears to be reusing a very small number of structures, and it is missing something real, which I will say up front rather than at the end. There is no genuine entanglement in the tabletop version. It uses a substitute that mimics the structure of entanglement without producing it, and because there is no second particle flying off down a long fibre, there is also no delay. You cannot demonstrate the delayed part on a kitchen table. What you can demonstrate is the erasure, and much more importantly, the one thing about the erasure that nobody shows you. Here is the construction. In the Maryland experiment, the root information about the signal photon is stored in a second photon. We do not have a second photon, so we store it somewhere else, in a property that the same photon already carries with it, namely its polarization. Light is a wave in the electromagnetic field, and that wave vibrates in a direction perpendicular to its travel. That direction is what polarization means. Put a horizontal polarizing filter in front of one slit, and a vertical polarizing filter in front of the other. Now every photon that gets through the barrier is stamped. Horizontal means it came through the first opening. Vertical means the second. The root information exists in full, and it is riding along inside the light rather than being carried away by a twin. Now put a screen up and look at what happens. The interference fringes are gone. This is not mysterious, and it does not require quantum mechanics to explain. Two waves can only cancel each other if they are doing the same thing in the same plane. A wave vibrating horizontally and a wave vibrating vertically have nothing to cancel each other with. They pass through each other and add up into something else without ever producing a dark band. The fringes are gone because the two paths now carry incompatible polarizations, and nobody has measured anything, and no detector exists anywhere in the apparatus. The mere fact that the roots are distinguishable in principle is enough. Notice how much of the strangeness has already been drained out of the phrase which path measurement. Nothing measured anything. 2 pieces of plastic film sat in front of 2 holes. It is worth pausing on how thoroughly ordinary the 2 filters are, because the ordinariness is part of the argument. Polarizing film is a sheet of plastic in which long chain molecules have been stretched into alignment, so that they absorb the component of the light's electric field running along their length and let the perpendicular component through. It was developed in the 1930s by a teenager who went on to found a camera company. It is the material in polarized sunglasses. It is in every liquid crystal display you have ever looked at, which means it is almost certainly between you and these words right now. 2 squares of it, cut with scissors, taped over 2 slits, are enough to destroy an interference pattern that has been the emblem of quantum weirdness for 100 years. Now for the analyzer, which is the rock. Calcite is calcium carbonate. It is the same compound as chalk, as limestone, as the shell of an oyster. But in one of its crystalline forms it does something remarkable, and it does it strongly enough that you can see it with your naked eye on a kitchen table. It splits light into 2 beams according to polarization. Lay a clear piece of calcite over a line of printed text and you see 2 lines of text. Clear specimens have been called Iceland spar for centuries, and their double refraction was being described scientifically as far back as the 1660s. There is a persistent piece of navigational folklore that Norse sailors use such crystals as a sunstone, finding the position of the sun through overcast skies by reading the polarization of scattered daylight. Whether they did or not is disputed. The physics is real. The light of the sky is polarized in a pattern centered on the sun. Set the crystal up one way, and it separates horizontal light from vertical light, which means, in our apparatus, it separates slit 1 from slit 2. Look at the far wall. There are two patches of light, one above the other. The upper one contains only photons that came through the first slit. The lower one contains only photons that came through the second. And each patch, if you look at it closely, is a single slit diffraction pattern. A blob. Wide central lobe, a couple of faint bands trailing off. That is a witch root measurement. That crystal, in that orientation, is doing exactly the job the two tattletale detectors do in Maryland. Now, the part that makes the whole thing worth building. Take hold of the crystal and turn it. 45 degrees. It is fiddly, and I want the fiddliness in the description because the honest version of this experiment is not a clean animation. The crystal is a small thing in amount, and getting it to exactly 45 degrees by hand takes a while. As you turn it, the two patches on the far wall slide and shiver and drift out of alignment with each other, for unavoidable reasons to do with the geometry, so that they are no longer stacked neatly one above the other. A cheap crystal makes noisy, imperfect, slightly smeared spots. Nothing about this looks like a diagram, but watch what the rotation actually does. In its first orientation, the crystal was asking a question. Are you horizontal or are you vertical? And because horizontal means slit 1 and vertical means slit 2, that question was the same question as which slit did you come from. Every photon had an answer, and the crystal sorted them accordingly, and the roots came apart. In its new orientation, the crystal is asking a different question entirely. It is asking about diagonal polarizations. Call them plus and minus. And here is the thing about horizontal light. Put to that question, it does not have an answer. It is not diagonal one way or diagonal the other. It is an equal mixture of both, and so it splits, half of it going to the plus output and half to the minus. And exactly the same is true of vertical light. So now both outputs contain light from both slits, in equal measure, thoroughly mixed. Point at the upper patch and ask which slit that light came through, and the crystal has nothing to say. Ask again in a different way and it still has nothing to say. The information is not gone. It is sitting in the polarization exactly where it always was, undiminished, and the crystal has simply been rotated into a position from which it cannot address it. That is what erasure is, not deletion, a change of question. And notice, because this is going to matter enormously in a few minutes, that nothing about this act is mysterious in the slightest. Nobody has reached backwards. Nobody has undone anything. A crystal was rotated. The light that arrives at that crystal is identical whether the crystal is turned or not. The light does not know, cannot know, and has no way to find out. All that changed is what happens to the light after it gets there. Now look at the wall. There are two patches again, and both of them are striped. The interference is back. On a table, in a dark room, in an apparatus with no entanglement in it, no coincidence counting, no computer, no timing window, and no delay. Just a laser, a barrier with two cuts in it, two scraps of film, and a rock turned 45 degrees. Total cost, if you're patient about sourcing the crystal, somewhere in the region of a nice dinner. And there is one more detail about those two striped patches, which is not a footnote and is not a curiosity, and which is the reason I made you build this thing in the first place. Look at where their stripes are. Part 9. Half a fringe. The two striped patches on the wall are not the same pattern. They are offset from each other, and not by some arbitrary amount that depends on how carefully you aligned things. They are offset by exactly half a fringe. Where the upper patch has a bright band, the lower patch has a dark one. Where the upper has a dark gap, the lower has a bright band sitting precisely in it. They are complementary. Physicists would say they are in antiphase. Everyone else can say they are interlocking, like the teeth of two combs pushed together. If you sketched one on tracing paper and slid it over the other, you would have to move it by half the width of a single stripe to make the bright bands line up, and at that offset every bright band of one sits in the exact centre of a dark gap of the other. Now do the obvious thing. Add them. Take the two patterns and lay them on top of each other, which is exactly what the crystal was doing automatically when you had it in its first orientation before you turned it, when it was throwing everything to one place. Every bright band of one falls into a dark gap of the other. Every peak lands on a trough. They cancel completely. And what is left when you add together two interference patterns that are perfectly out of step with each other is a smooth, broad, featureless hump. It is the blob. I told you to remember it. It is the same blob you get from the witch root measurement, not a similar shape, the same shape. The total pattern is identical whether the information was erased or not, whether the crystal was rotated or not, whether anybody did anything at all. Which means the single-slit pattern, the thing we have been calling the shrug of the experiment, the boring result, the shape that shows up when nothing interesting is happening, was never the absence of interference. It was two interference patterns superimposed and cancelling the whole time. I want to give that a moment, because I think it is one of the more elegant reversals in physics, and it goes past most people in about 4 seconds. Everything we have built tonight rests on the idea that measuring the root destroys the interference. It does not. It never did. Nothing is destroyed. What happens is that the two interference patterns, which are always both present, get thrown into the same place and cancel each other out, and the sum of two cancelling patterns is a smooth curve, and a smooth curve looks to the eye exactly like the absence of a pattern. Rotating the crystal did not bring the interference back. The interference had never left. Rotating the crystal separated the two patterns and sent them to different places, so that instead of adding up and cancelling, they landed side by side where you could see them. Nothing was erased, something was sorted, and that same reversal runs backwards through everything we established in the first half of this video. Go and look again at the Maryland result with this in your hands. The two graphs from the tattletale detectors are smooth humps. The two graphs from the eraser detectors have stripes. Add the two striped graphs together and you get a smooth hump, which means that the sum of the eraser results and the sum of the tattletale results are the same curve. There is no experiment you could do on the signal side alone that would distinguish them. The strangeness we spent an hour building was never on the screen. It was in the comparison between two lists. And here is why I made you build that thing with the laser and the rock, and why I spent so long on the fiddliness of turning a crystal by hand. You do not have to take my word for any of this. You do not have to take a physicist's word for it, or trust a paper you cannot read, or accept a summary from a person on the internet with a microphone. You can put it on a wall. In a dark room, for the price of a decent meal, you can watch a paradox that has confused careful people for 25 years come apart into two patterns of light that do not quite line up. There is something almost humiliating about the smallness of it, and I say that as someone who was thoroughly taken in. It is not a new theory. It is not a hidden assumption, or a subtle move about the nature of time, or a reinterpretation that requires you to give up realism or locality or free will. It is addition. Two curves, added, cancel. That is the entire counter-argument. I spent years finding this experiment profound, and the thing that undoes the profundity is a sum you could do on a napkin, and I never did it, and neither did almost anybody else, because it did not occur to us that the answer would be that cheap. There is a second reversal hiding inside the first, and it is worth pulling out because it changes what the whole experiment is about. If both interference patterns are always present, and measurement merely determines whether they land on top of each other or side by side, then the thing we have been calling a witch root measurement is not really an act of interrogation at all. It is an act of routing. The crystal in its first orientation and the crystal in its second orientation are both just sorting machines. They differ only in which property they sort by. Nothing in either arrangement asks the photon a question and receives an answer. Nothing collapses in the dramatic sense the word suggests. Light goes in, and depending on how a piece of stone is oriented, it comes out arranged one way or another. That reframing costs you the entire mystical vocabulary of the subject, and it is worth noticing how much of the strangeness was living in the vocabulary, rather than in the physics. Now I can hear the objection forming, and it is a good one. Is that offset a coincidence? It seems awfully convenient that the two patterns should cancel exactly. If they were offset by a third of a fringe, or by some untidy amount that depended on the apparatus, then their sum would still have some structure in it, and then the total would depend on whether you had erased or not, and then something would genuinely be strange. The offset is not a coincidence. It is forced, and it is forced by the most ordinary component in the whole optical draw. A beam splitter, the half-silvered mirror that recombines the two roots in the Maryland experiment, and the second orientation of the crystal in ours, has two outputs, and it imparts a relative phase shift between them. It has to. Think about what would happen if it did not. If both outputs got a bright fringe at the same position, then at that position you would have more light coming out of the device than went into it, and at the corresponding dark positions you would have less, and light would be appearing and disappearing depending on where you put your detector. Energy would not be conserved. The universe does not do that. So the two outputs of any two-port interferometer are complementary. They must be. Whatever one gains, the other loses, at every position, exactly. Their sum is featureless because their sum has to be featureless, because the sum is just all the light that came in, redistributed. You can put it even more plainly than that. A beam splitter is a sorting machine, not a factory. It takes what arrives and sends it to one of two places. The total is conserved because the total was never in question, which means the resolution of the delayed choice quantum eraser is not a subtle result from the frontier of quantum foundations. It is built into the behavior of a piece of half-silvered glass, and it has been sitting there since the 19th century, and every single person who has ever taught an optics course knows it. There is a particular flavour of frustration in that, and I do not think it reflects badly on anyone in particular. It is simply what happens when a field's routine knowledge and a field's public story drift apart, and nobody notices for a quarter of a century because the two audiences never sit in the same room. I said earlier that the reason this fact never appears in the retellings is that it is boring. I stand by that, and it is worth understanding why, because it explains a great deal about how physics reaches the public. The interesting part of the Marilyn result is that 2 of the 4 graphs have stripes. The relationship between those 2 graphs is a technical detail about phase. It does not photograph well. It cannot be animated dramatically. It requires you to look at 2 plots at once and notice that their peaks do not line up, which is precisely the kind of observation that gets cut when a 40-page argument is compressed into 90 seconds. And so, over 25 years and thousands of retellings, the load-bearing fact fell out and the mystery walked on without it. There is one immediate consequence of the antiphase offset, and I am going to state it now and leave it half-explained because we need the next part before it can be finished. Suppose the offset did not exist. Suppose the 2 eraser outputs gave the same fringe pattern instead of complementary ones. Then their sum would be striped. Then the total pattern would look different depending on whether the eraser was engaged or not. Then a person sitting at the screen could see, directly, without being told anything, what had been decided at the other end of the apparatus, including, in the Maryland arrangement, decisions that had not been made when the photons landed. That would be a message, travelling backwards. The antiphase offset is the reason it is not. That half fringe of misalignment, the little slippage between 2 patterns of light that you can see with your own eyes on a wall in a dark room is the lock on the door. And now we need to go and look at what the person watching that screen actually sees. Part 10. What she actually sees. Go back to Maryland. 2 people at opposite ends of an optical table. Call the one watching the signal photons Alice, and the one at the far end with the 4 idler detectors Bob. That is how these things are always described, and it saves a lot of words. What does Alice see? She sees the sum. She has no choice about it. Her detector is a photon counter on a stage. It registers arrivals. It has no way of knowing which of Bob's 4 detectors fired 8 nanoseconds later, because that information is at the other end of the apparatus, in a different file, on a different channel. Every signal photon that arrives goes into the same tally. She cannot separate them because she has nothing to separate them by. And we have just established what the sum is. It is the blob, the smooth, featureless hump, the single slit envelope, 2 interference patterns cancelling each other into a curve. So Alice's pattern is a blob, on every run, under every configuration. No matter what Bob does, no matter what he decides, no matter when he decides it, no matter whether his apparatus is turned on at all. Let me put you at her station for a shift, because the emptiness of it is the point. It is an 8-hour run. The counter steps along its track, position by position, pausing at each one, accumulating. A number climbs on a screen, the stage advances a fraction of a millimetre, another number begins to climb. There is nothing to watch. The plot builds itself out of the left-hand side toward the right. A slow rise, a shoulder, a peak, a fall. Somewhere behind her, at the far end of the table, photons are arriving at 4 detectors and taking one branch or another for no reason at all, thousands of times a second. None of it reaches her. You could walk into that room halfway through and tell her that the eraser had been engaged for the last 4 hours. Her plot would look the same. You could tell her the eraser had been disengaged, or that it had been engaged for the first hour and then switched, or that Bob had gone home at lunchtime and the far half of the apparatus had been sitting dark and unpowered since. Her plot would look the same. You could tell her that Bob's optical bench had been physically dismantled and carried out of the building. Her plot would look the same. She finishes the run holding a smooth curve, and this is not a fact about the limitations of her equipment or the patience of the experimenters. It is a theorem. It has a name, the no-signaling theorem, and it says that nothing done to one member of an entangled pair can alter the statistics observed on the other member considered on its own. Not slightly, not subtly, not in a way that would show up with better detectors or longer runs. The distribution Alice sees is mathematically guaranteed to be independent of everything Bob does. It is not that nobody has managed to make her screen change. It is that the theory forbids it, in the same way and with the same force that it forbids energy from appearing out of nothing. The fringes are in her data. They are in there right now, in the list of positions she has just spent 8 hours accumulating in 2 interlocking halves. She cannot see them, and without something arriving from the far end of the apparatus, she never will, and no amount of cleverness applied to her own numbers will get them out, because the information required to separate the 2 halves is not in her file at all. So how do the fringes get out? Somebody carries Bob's data over. That is it. That is the whole mechanism. Bob has a list, and his list says, at this timestamp detector 3 fired, at this timestamp detector 1 fired, and so on, for the whole 8 hours. Alice has a list of positions and timestamps. Somebody puts the 2 lists side by side, matches them up pair by pair using the timing window, and then throws most of the data away. Keep only the signal events whose partners hit one particular eraser detector. Plot what survives. That subset is striped. Keep the other eraser detector's partners instead, and plot those. That subset is striped too the other way, offset by half a fringe. Put both subsets back and the stripes cancel, and you're looking at the blob again. I want to name that act of carrying the data over, because everything from here on is going to keep coming back to it. Call it the phone call. In practice, it is nothing so romantic. It is a file transfer, or an email, or a physicist walking down a corridor with a laptop, or these days just 2 data streams landing in the same directory on the same machine. It is the least interesting event in the entire experiment. It involves no quantum mechanics whatsoever. It is bookkeeping. If the experiment were done today with the 2 halves in different cities, the phone call would be an ordinary internet packet subject to ordinary latency, arriving no faster than light and no earlier than it was sent. And it is the only reason anybody has ever seen a fringe in this experiment. Now hold the 2 halves of that in your head at once, because this is the distinction the whole video has been walking toward. There is a difference between a pattern that exists and a pattern that is extracted. Alice's screen has a pattern on it. That pattern is a blob. It was a blob from the first photon. It stayed a blob for 8 hours, and it will be a blob in the file forever. The striped patterns are not on her screen. They are extracted from her data afterwards, by a sorting rule that has to be physically delivered to her from somewhere else, travelling forward in time at ordinary speed like everything else. The sorting instruction arrives late. The data it sorts does not change when it arrives. Let me offer you an analogy, and then immediately tell you where it fails, because a good analogy that you do not know the limits of is worse than none. Imagine a very large hall full of people. This morning each of them flipped a coin and wrote the result on a card and put it in their pocket. Tonight, you walk in and you invent a rule for dividing the hall into 2 groups. You apply your rule. Then everyone takes out their card. Group 1 turns out to be almost entirely heads. Group 2 is almost entirely tails. Did your rule, invented tonight, change what they flipped this morning? Obviously not. You sorted them. The cards were written hours ago and nobody touched them. The only genuinely interesting question is how your sorting rule managed to track the flips, and if the rule was built out of information that was correlated with the flips all along. If, say, everyone with heads had been given a red ticket at the door, then there is nothing whatsoever to explain. That is the shape of the resolution, and it is correct as far as it goes. Now here is where it fails, and the failure is not a flaw in the analogy so much as the entire remaining subject of this video. In the hall, every card had a definite value all morning, sitting in a pocket, waiting to be read. Heads or tails written down, a fact about the world whether or not anyone looked. There is no such value in the quantum case. The root was never a fact. There is no card in the pocket. The correlation between Alice's data and Bob's is not a correlation between 2 pre-existing records, and we know that it is not, because correlations of that kind have limits, and quantum correlations exceed them. That is what the Bell experiments established over decades, and it is the most thoroughly tested result in this entire field. So the coin hall explains, completely and correctly, why nothing travelled backwards in time, and it does not explain, and cannot explain, what is actually going on. It removes the time travel and leaves the strangeness exactly where it was. There is a version of this that makes the point even more cleanly, and it is worth 30 seconds. Suppose Bob never sends his data. Suppose his hard drive fails, or he loses interest, or the funding runs out and the far half of the experiment is packed into boxes without anyone ever reading the file. Alice is left holding 8 hours of positions and a smooth curve. The information required to pull the stripes out of it existed once, and is now gone. Is her data now different from what it would have been if Bob had sent it? No, it is byte for byte identical. The only thing that changed is what she's able to do with it. And that is a fact about her, and about a filing system, and about the availability of a second list. Not a fact about photons, and certainly not a fact about the past. Before we go there, some housekeeping, because I have been describing this like a photograph and it is not one. Everything in the Maryland result is counting statistics accumulated over long runs. The recovered fringes have good visibility but not perfect visibility, because real detectors register events that were not there. Real timing windows admit accidental pairs from different parents, and real crystals produce imperfect entanglement. None of that affects the argument, and the two subsets are not some rare tale cherry-picked from the data. A photon reaching that beam splitter has an even chance of going either way, so the two eraser subsets are two halves of the events, and together with the two tattletale subsets they exhaust the whole dataset. Nothing is being hidden in the discards. You can check this yourself in any published version of the result. Add the 4 coincidence curves together and you recover, within noise, the total count rate that Alice recorded, unsorted, all along, so nothing went backwards. Which leaves a question that I think is worse, and that almost nobody asks because everyone is so relieved to have disposed of the time travel that they stop there. If nothing went backwards, what went forwards? Part 11. The arrow that will not stay pointed. Grant the retrocausal story one more minute of life. Suppose the correlation between what Bob's detector does and what Alice's data looks like really is causal, that one of them really does make the other happen. Which way does it run? The story says Bob causes Alice. His later decision determines her earlier pattern. Fine. But watch what happens when you tell it in reverse, and notice that nothing in the data prevents you. Take a single pair. Alice's signal photon arrives at her counter and lands at some particular position, and suppose that position happens to sit right on a bright band of one of the two fringe patterns, call it the minus pattern, and correspondingly right in a dark gap of the other one, the plus pattern. That is now recorded. It happened. 8 nanoseconds later, its twin reaches Bob's beam splitter and ends up at one of the two eraser detectors, producing either a plus result or a minus result. Could it produce a plus? Not really. That combination barely occurs. The plus pattern has a dark band exactly where Alice's photon landed, and a dark band means very few events, and so the pairing of that landing position with a plus outcome is close to absent from the dataset. Alice's photon landed where it landed, and the correlation is exact, so Bob's later result is effectively forced. Alice determines Bob, and notice what that story has going for it. The cause happens first, and the effect happens second. The arrow points forward. Nothing peculiar occurs at all. It is exactly as boring as the retrocausal version is exciting, and it fits the data precisely as well, because it is the same data described from the other end. So we have two accounts, mirror images of each other, both consistent with everything ever measured, and no way to choose between them. That should already be a warning. When a causal question has two equally good opposite answers, the usual reason is not that the answer is hard, it is that the question has broken. You see the same signature elsewhere. Ask which of two people in a tug-of-war is pulling and which is being pulled, and the question sounds sensible until you notice that the rope does not distinguish them. There is a tension in the rope. There are not two events, one of which caused the other, but there is a sharper version of the problem, and this is the one I want to hand you, because it turns a philosophical stalemate into a physical fact you cannot argue with. The order is adjustable. The whole reason the Maryland experiment is called delayed choice is that the idler's path was about 2.5 meters longer than the signal's. That is a piece of geometry. It is a length of glass and air and a couple of extra bounces. You can change it, shorten the idler's path, lengthen Alice's, and you can arrange for Bob's detection to happen before hers. Run the experiment that way, and everything comes out identically. Same fringes, in the same sorted subsets, with the same half-fringe offset between them, at the same visibility. Nothing about the result knows or cares which detector fired first. Now think about what that means for the retrocausal story. If there were a real influence travelling backwards in time from Bob's measurement to Alice's photon, then removing the backwardsness ought to matter enormously. In one configuration, the influence has to go against the direction of time. In the other, it goes with it. Those are wildly different physical situations, and the experiment cannot tell them apart. You could hand a physicist the 4 graphs from a run, and they would have no way of determining from the data alone which detection came first. That is not what a causal mechanism looks like. That is what a correlation looks like. There is a useful rule of thumb buried in that. If you can reverse the temporal order of 2 events, and nothing whatsoever changes in the outcome, the temporal order was not part of the physics. It was part of your description. And a delay that makes no difference to anything is not a delay in any sense that matters. It is a length of fibre, and then relativity closes the door and locks it. Alice's detector and Bob's detectors are a few meters apart on the same optical table, and the events we are comparing are separated by nanoseconds. That combination, a few meters of space, a few nanoseconds of time, puts these 2 events in a very specific regime. They are close enough together in time, relative to the distance between them, that light could not comfortably travel from one to the other, and for 2 events like that, special relativity says something that people find hard to believe the first several times they hear it. There is no fact about which one happened first. It is not that we do not know. It is not that our clocks are insufficiently good. Different observers, moving at different speeds relative to the apparatus, will disagree about the order of those 2 detections, and every one of them is correct. An observer travelling one way through the laboratory sees Alice's detection first. An observer travelling the other way sees Bob's first. Someone standing still sees them in whatever order the fibre lengths dictate. All 3 are describing the same universe, and there is no privileged one among them, and the equations of physics work identically for all of them. This is not exotic physics reserved for spacecraft. It is the ordinary content of special relativity, tested to extraordinary precision for over a century, and it is the same effect that keeps satellite navigation honest. So consider what that does to the question we have been arguing about. Which one went first? It was the load-bearing fact of the entire paradox. The whole reason this experiment is startling is that the signal photon was recorded before the choice was made. Take that away and there is nothing left to be startled by, and it is gone. Not answered, gone. The ordering depends on how fast you happen to be moving. Get on a train, and the cause becomes the effect. A cause whose direction depends on how fast you're moving is not a cause. I want to leave that sitting there for a moment without explaining it, because I think it is the real content of this video, and it is easy to skate past. What is being taken away here is bigger than the time travel. You came in worried that the future might be able to edit the past, and we have answered that. It cannot, and the answer is a piece of arithmetic about 2 offset patterns and a theorem about statistics. That is settled. But the question underneath it, which one made the other happen, does not have an answer either, and not because nobody has found it yet, and not because the experiment was insufficiently clever, because the universe does not carry one. The correlation is exact. It is enforced without a single exception in any laboratory that has ever tested it, and it has no direction. Physics guarantees that Alice and Bob will agree, and refuses to say who made whom agree, and there is no mechanism on offer. No signal passes between them. The no-signalling theorem rules it out, and the theorem is not a lucky accident. It falls straight out of the structure of the mathematics. No field carries anything. No influence propagates. There is a joint state describing the pair, and it simply does not come apart into 2 separate things with 2 separate histories that could stand in a causal relation to one another. The pair is not 2 things. Our insistence on describing it as 2 things is where all the trouble starts, and there is a name for that mistake in the critical literature, which we will get to shortly. If you want the most extreme version of this, it exists, and it was done. It is called delayed choice entanglement swapping, and the idea was proposed at the turn of the millennium and realized in Vienna in 2012. In that experiment, the decision about whether 2 particles should be described as entangled with each other at all is made after both of them have already been measured and destroyed. The particles are gone. There is nothing left to influence, not even in principle. The Vienna group used a quantum random number generator to make that choice in the time-like future of the other two detections, so nothing could have got there first. And the answer comes out the same. The choice does not change the past. It changes what description you are entitled to apply to the past. And here is where the phone call comes back, because it is the same lock on the same door. In every one of these experiments, without exception, the interesting structure only appears when two lists are brought together, and bringing two lists together requires an ordinary message travelling forward in time at ordinary speed. There is no protocol in quantum mechanics, not teleportation, not entanglement swapping, not this, that does not stall at that step. The quantum part is fast and strange and does whatever it does, and then everybody waits for the email. That is not a coincidence, and it is not a limitation of current technology. It is the structure of the theory. Einstein spent the last 20 years of his life unhappy about precisely this, and he did not have the eraser or the swapping experiments or any of the modern apparatus. He had the bare structure, and the bare structure was enough. He called it spooky action at a distance, and he meant it as an insult, and he was pointing at exactly the thing we have just arrived at from the other direction. A perfectly enforced agreement with nothing visible enforcing it. He thought that was a sign the theory was incomplete, that there had to be something underneath filling in the gap. Decades of experiment have since ruled out the specific kind of something he had in mind. The gap stayed. Now, all of this is me telling you things. You should not take my word for it either. Let us go and see what the physicists actually wrote. Part 12. What the physicists actually said. The published critical literature on this experiment is not a lonely descent. It is a body of work produced independently by different people, arriving from different directions across the 2010s and into the 2020s, and it reaches the same conclusion every time. There is no serious published defense of the naive retrocausal reading. There are careful papers arguing about how best to describe what is going on, and there are legitimate disagreements about interpretation, and there is not one respectable analysis claiming that a later measurement alters an earlier event. One of the sharpest of these puts its objection directly in the title, arguing that the delayed choice quantum eraser neither erases nor delays, and that whatever apparent retrocausal effect people are pointing at is entirely exhausted by ordinary entanglement correlations, with nothing extra required and nothing travelling backwards. The technical form of the objection is worth stating in plain language because it is precise, and it is the crux. The signal photon, considered on its own, is described by something physicists call an improper mixture, and the essential property of that description is that it has no preferred basis. It does not physically prefer to be thought of in terms of roots, rather than in terms of interference, or the other way round. Those are two equally valid ways of carving up the same object, and neither one is what the photon really is underneath. The retrocausal reading smuggles in the assumption that the photon was in one of those descriptions before anybody looked at the correlation, that it was really taking a root, or really being a wave, and then asks what changed it. Nothing changed it. The premise was wrong. A related critique gives the underlying error a name that I find genuinely useful: the separation fallacy. It is the habit of treating an entangled pair as two things, each with its own state, so that a measurement on one becomes an action performed on the other. There are not two things with two states. There is one joint state. Neither photon has a state of its own for a later measurement to reach back and modify, because neither photon has a state of its own at all. Almost every version of the paradox you have ever heard is built on that separation, and the paradox does not survive giving it up. And giving it up is genuinely difficult, not because the physics is hard, but because our language has no comfortable way to talk about one thing that is in two places and is not two things. We have nouns and we have plurals, and entanglement sits in the gap between them. I want to say something about the people who got this wrong, including me, because contempt would be both unpleasant and unearned. There is a real phenomenon of popular explainers who covered this experiment years ago going back and publishing corrections, saying plainly that their earlier account was mistaken. That takes a particular kind of nerve when your earlier account is still sitting there being watched by people every day, and I think it deserves to be noted rather than used as ammunition. And the reasons so many careful people believed it are not stupid ones. The paper's own framing invited the reading. The presentation of 4 separate graphs naturally focuses attention on the 2, with stripes in them, because those are the interesting ones, and the relationship between those 2 graphs is a technical remark about relative phase. The half-fringe offset, the single fact that dissolves everything, is visually dull, resists animation, and is the first thing to be cut when an argument is compressed. This is a failure of communication, not a failure of physics, and the physics has been sitting in the open the whole time. Now, let us deal with what has grown on top of it, because a misreading this widespread does not stay in physics. The most common thing built on this experiment is a manifestation claim, that because a later choice appears to determine an earlier outcome, a person can influence their own past by choosing what to attend to now. Some version of this circulates very widely, usually attached to a garbled account of the Maryland result. The answer is the theorem. The statistics available to the person at the earlier end are provably, mathematically unchanged by anything done at the later end. Not almost unchanged. Not unchanged in practice with current equipment. Unchanged as a matter of proof. There is no channel, not a weak one, not a subtle one, not one that only opens for the sufficiently focused. Whatever the correlations are doing, they cannot be used and they cannot be aimed, and this is not a restriction imposed from outside the theory, but a consequence of its structure. The second is the backwards message claim, that this demonstrates a mechanism for sending information into the past, one that might one day be engineered. The answer to that is the half fringe. The two eraser outcomes produce complementary patterns whose sum is featureless, which means the receiver at the earlier time is staring at an unchanging blur no matter what the sender does. There is exactly one channel available, and it is the sorting, and the sorting instruction has to be physically carried forward in time at ordinary speed. Every backwards messaging scheme ever proposed in this space forgets to mention the phone call. The third is a suppression story, that physicists know this proves retrocausality and are keeping quiet. The record says otherwise, loudly. Physicists have published extensively and publicly on exactly this question, in open journals and on open preprint servers, for years, and they have mostly been arguing with each other about how best to explain why the retrocausal reading fails. The confusion is a naming problem and a popularization problem. Nobody's hiding anything, and it would be a strange conspiracy that conducted itself entirely in searchable public documents. The genuinely interesting sociological question is not why physicists hid the answer. It is why an answer that was never hidden failed, for 25 years, to catch up with the story. I do want to leave one door properly open, because closing it would be dishonest. Genuinely time-symmetric formulations of quantum mechanics exist, and they are serious professional physics, not fringe work. There is a formalism developed from the 1960s onward, in which a system is described by two states, one evolving forward from how it was prepared, and one evolving backward from how it will be measured. There is an interpretation from 1986 that describes every quantum event as a kind of handshake between a wave going forward from the emitter and a wave coming backward from the absorber. Both are mathematically equivalent to standard quantum mechanics. Both make identical predictions. Both are careful to note that their backwards influence is uncontrollable and cannot be used to signal, which is precisely what makes them interpretations rather than new physics. So it is not true that physics has ruled out time symmetry. It has not. What is true is that this experiment does not motivate it, does not require it, and does not distinguish it from any of the alternatives, and that is the shape of the whole interpretive situation, which is worth a sentence before we finish. The standard minimal account says there is nothing to explain. Conditioning is not causation. Many worlds says nothing ever collapsed, so nothing was erased or restored. Pilot wave theory says the particle had a definite route the entire time, and a guiding wave carried the correlation at the cost of explicit non-locality. The relational accounts say there was never an observer-independent fact about the route to begin with, and Wheeler's own answer, which we heard in the first half, says no phenomenon until it is a registered phenomenon. 5 sophisticated worldviews, every number identical, no experiment able to separate them, including this one. There is something clarifying in that, and it tells you something true about the edges of physics that no single interpretation could. The equations are finished. The story is not. And that gap is not going to close by running this experiment again with better detectors. All 5 accounts predict the same numbers, so no measurement can separate them. The one family of ideas that does make different predictions, models in which the wave function collapses physically, on its own, at a rate that depends on mass, is being actively squeezed by experiments looking for the faint heating such a mechanism would produce, and the space it has left to live in gets smaller every year. Everything else is a difference in what the same mathematics is a picture of. But notice what every single one of those critiques has in common. They all answer the question we came in with. Not one of them touches the question underneath it. Part 13. What is actually terrifying? So here is the answer, plainly, with no more delay. No, the future does not change the past. Nothing in the delayed choice quantum eraser reaches backwards. There is no message, no influence, no edit, no hand going back to rub anything out. The screen never changed. The screen could never have changed. What looked like a rewriting of history was two interlocking patterns of light, always both present, being sorted into the same place or into different places, and then a list being carried across a room. If that were the whole story, this would be a video about a misunderstanding, and it would end here, and you would go to sleep slightly reassured. It is not the whole story. There are three things left, and each one is worse than the thing it replaced. The first is the one that has been standing quietly behind everything since the first 10 minutes. There was no past there to change. Go back through what we actually found. The root was never a fact. Not a hidden fact. Not a fact somebody failed to measure. Not a fact sitting in a drawer waiting for the right instrument. Absent. When you insist on describing the signal photon as having taken one route or the other, before anyone examined the correlation, you are describing an object that does not appear anywhere in the physics. That is what the improper mixture with no preferred basis means. That is what the separation fallacy is a fallacy about. The photon did not have a state of its own to be modified, because the pair does not come apart into two things. Wheeler said this in 1978, in as many words, and almost nobody listened, because what he said sounds like a philosopher's evasion until you have spent 2 hours finding out that it is a description of the mathematics. No elementary phenomenon is a phenomenon until it is a registered phenomenon. Now sit with what that does to the word past. The comfort you have been carrying, that what has happened is finished and therefore safe, was never the comfort you thought it was. It is not that the past is fixed. It is that some things become fixed at the moment they get recorded, in the sense of leaving a trace in enough of the world that the trace cannot be undone. Before that moment there is no it, not an unknown it, no it. Which means the past is not a place. It is not a filing cabinet with everything in it, some drawers open and some closed. It is a much thinner thing than that. It is exactly as much as got written down, and no more. There is a strange consolation buried in that, and I do not want to pretend there is not, because this video would be dishonest if it left you only with the vertigo. If the past is only as much as got recorded, then it is also far more solidly recorded than any photon ever was. You're not a pair of entangled particles on an optical bench. Everything that has ever happened to you happened in a world made of air and warmth and light, saturated with things that interact, and every event of your life was written into that world within a fraction of a second of occurring, in more copies than could ever be gathered back in. The reason your past holds still is not that holding still is a law. It is that you live somewhere that takes an enormous number of notes. The second thing is the one I think is genuinely the most unsettling fact in this entire subject, and I do not think it gets a fraction of the attention it deserves, because everyone is so busy arguing about time travel that they walk straight past it. The correlation is exact. It is enforced without a single exception in every laboratory on Earth that has ever tested it, at every scale anyone has managed to build. It is frame independent, meaning it does not care about the order of the events, which is another way of saying it does not care about time, and it is causally unassignable. You cannot say which measurement made the other come out the way it did, because the order depends on how fast you're moving, and because the mathematics does not distinguish them, and because there is no signal, no field, no carrier, no mechanism of any kind on offer. The universe keeps a promise, perfectly, forever, and there is nothing in the universe doing the keeping. That is what I meant at the very beginning when I said the answer would not be a relief. Retrocausality, for all its strangeness, is at least a story. It has an actor and a direction, and a mechanism and a moment of contact. Something reaches out and touches something. You can picture it, you can draw it, you can be frightened of it in the ordinary way you're frightened of things that could happen to you. Take it away, and what stands in its place is not a smaller mystery. It is a rule with no enforcer, an agreement with no negotiation, a consistency that is never once violated and has nothing holding it in place. Einstein could not accept it and spent 20 years saying so. Nobody has solved it. A century of the most successful physical theory ever written, tested to more decimal places than anything else in science, and this sits in the middle of it, unexplained, load-bearing, and quietly waiting. The quantum eraser is not the reason it is true. It is simply one more window you can stand in front of and look directly at it. There is one more way to feel the shape of it, and it is the reason the word terrifying belongs on this and not on the time travel. Every frightening thing you can name has a mechanism. Illness has a mechanism. Loss has a mechanism. Even the heat death of the universe, which is about as final as anything gets, is a consequence of a rule you can write down and follow forward step by step until there is nothing left. Fear, as a piece of equipment, is built for mechanisms. It exists to help you get out of the way of causes. This has no mechanism. There is nothing to get out of the way of. There is simply a set of facts about the world that agree with each other more exactly than anything in your experience agrees with anything, for no reason that can be stated in any language, in any order, from any point of view. It is not a threat. It is not coming for you. It is just there, underneath everything, holding, and nobody can say why. And there is a third thing, which is the one I want to leave you with because it is open. Go back to the dark room and the crystal turned 45 degrees. 2 patches on the wall, both striped, offset by half a fringe. A photon comes through the apparatus and joins one of those 2 patterns. Something sorts it. One goes here, another goes there. What? On the standard account, nothing does. It is irreducibly random, weighted by a rule that tells you the odds and refuses to tell you anything else, and the question of why this particular photon went to this particular pattern has no answer. Not a hidden one, none. On the pilot wave account, the answer is the particle's exact position, at the moment it entered, which is real and definite and in principle unknowable. On many worlds, both happen, and there is no fact about which one is yours, and the property that actually does the sorting, if there is one, is right now an open question in the foundations of physics, argued over by people who have spent their careers on it and cannot agree. Nobody knows. That is not a rhetorical flourish, and it is not a way of ending on a nice note. It is the state of the field. There are people alive right now who will spend the rest of their working lives on that question, and there is a reasonable chance that none of them will settle it, and a small chance that one of them will, and no way at all to tell in advance which. So what the quantum eraser experiment reveals about reality is terrifying, and it is terrifying for none of the reasons it is usually sold. Not because the past can be changed. It cannot. Because for a great deal of the world there is no past at all until something writes one down. Because every fixed thing you have, every settled memory, every closed conversation, every fact about yesterday you would go to the wall for, is fixed for one reason only, which is that something, somewhere, recorded it, and the record spread far enough into the world that it cannot be gathered back in. That is what makes a thing real, as far as anyone can tell. Not that it happened, that it was written down. And underneath that, holding everything in place, running perfectly, never once caught out, is a set of agreements between things that were never really 2 things, kept by nothing at all. The blob on Alice's screen looked like the least interesting object in the experiment. It looked like the place where nothing was happening. It turned out to be the most crowded thing in the room. I suspect the past is the same.